Here's an example of a really common question that a lot of students get wrong. I want to make sure that you don't. This is a great test of how well you understand oxidation and reduction. So here's a question. Does the following chemical equation, this chemical equation right here, represent an oxidation-reduction reaction? So is this an oxidation-reduction reaction? You can think about this for a minute, pause the video, and then we'll talk. So what do you think? Is this an oxidation-reduction reaction? Well, most people say yes, it is. But actually, the correct answer is no. This is not an oxidation-reduction reaction. So if you got this wrong, I'm not a professional mind reader, but I want to try to read your mind right now and guess why you thought this was a redox reaction. I'm guessing it's because you saw the plus and the minus, you saw these charges here, and you realized we were dealing with ions, and you thought, yeah, pluses, minuses, charges, ions, these are things that we see in oxidation-reduction reactions. Well, you're half right. We do see those in oxidation-reduction reactions. But just because an equation or a reaction has charges and ions doesn't mean that it has to be an oxidation-reduction reaction. Remember what these two words mean. In order for something to be an oxidation-reduction reaction, we have to see electrons transferred between atoms. That's not going on here, and let me show you how I know that. So KCl here is an ionic compound, which means that it's made of ions, the K plus ion and the Cl1 minus ion. So these atoms have charges, and we can even write numbers above these atoms to reinforce what charge they have. 1 plus for the K, 1 minus for the Cl. Now, over on this side, let's take a look at what's going on. For this to be an oxidation-reduction reaction, the K and Cl would have to have a transfer of electrons that create these charges, the plus and the minus. But the atoms over here, they already have charges, right? K plus, here's a picture of the atom. Cl1 minus, here's a picture of the atom. And I can put these numbers above them. Got 1 plus for K, 1 minus or minus 1 for Cl. So the point of this equation here is that the charges don't change. K and Cl start out plus and minus, and they end plus and minus. There's no transfer of electrons that takes place. The only thing that happens is two atoms that started out charged end up sticking together. That's the only thing that's going on in this equation. Now, if this still is a little bit confusing, let me show you how we could change this equation to make it actually an oxidation-reduction reaction. And then when you see the differences, I think this will all make sense. So here's the equation that we said was not a redox reaction. Here's an equation that is a redox reaction. These two reactions look pretty similar except for one important difference. Take a look at how K and Cl start out. In this equation up here, they had charges. In this equation down here, they don't have charges. They start out not as K plus and Cl minus, but as neutral atoms as K and Cl. To emphasize that they're neutral, we can put these oxidation numbers, these zeros, above them. The zeros tell us that they're neutral. And then just like before, KCl is an ionic compound with K plus and Cl minus. Here are the charges for those atoms. So, in order for K and Cl to become K plus and Cl minus, there has to be a transfer of electrons. So what happens is K, potassium, gives up one of its electrons, it gives it to Cl. K loses one of its electrons to become K plus or potassium 1 plus. Cl gains one of these electrons and becomes Cl minus, chloride. So now these two atoms end up with charges, but only because of a transfer of electrons. That transfer of electrons caused potassium, K, to become oxidized, and it caused Cl, chlorine, to become reduced. So that's why this is an oxidation-reduction reaction, because potassium and chlorine, K and Cl, start out neutral. There's a transfer of electrons which gives them charges, and then those charges stick together. The reason why this here was not a redox reaction is because potassium and chloride started out already with charges. So we didn't need this transfer of electrons to give them the charges. So if you ever run into a question like this, remember, just because an equation has pluses and minuses doesn't mean that it's an oxidation reduction reaction. For something to be an oxidation reduction reaction, you've got to see a transfer of electrons. This equation wasn't a redox reaction because there was no transfer of electrons. Two things that started out as +1 and -1 just stuck together. They were still +1 and -1 at the end. This equation, though, it was a redox reaction because these two things started out neutral, K neutral and Cl neutral, and the K got oxidized to 1+ by losing an electron. The Cl got reduced to 1- by gaining an electron. The charges changed because electrons were transferred, and that's why this is a redox reaction, and why this, because the charges are the same the whole time, that's why this is not.